Hello everyone, welcome to Automation Community. Today in this video, we are going to develop ladder logic from Boolean expression. So let's start. Example 12. Y is equal to AB plus C and Y is equal to A, BC plus D. So we will start with the first one, that is Y is equal to AB plus C. So there is AND gate between A and B. So we will connect two normally open contacts for A and B in series, and then AB and C has NOR gate. So AB in series and that C will be connected in parallel with AB. Thus we will implement OR logic gate. So let's move to TI portal where we will draw the ladder diagram. So this is the interface of TI portal. So firstly, we'll go to PLC tags and then default tag table. And here we will add some inputs A, then we have B, then we have C, and we will also add D for the next example. And then we have output Y here, and for that I will change the address to Q 0.0. Okay. So here we have four inputs, and for the first example, we will be using only three inputs A, B, and C, and the output is Y. So after that, we will minimize this and we will go to program blocks and main OB. So here we will be drawing ladder diagram. So firstly, I will insert a normally open contact for A. So I'll insert a normally open contact, one more normally open contact, and a coil. So this will be A, and then it will be B. This one will be B. So it is AB. So AB means A and B are connected in series, thus implementing AND logic gate. And then this coil will be used for the output, that is Y. And then we have AB plus C. Plus means OR logic gate. So we will add one more normally open contact for C, but that will be connected in parallel with this AB. So here we will open the branch and then we will insert a normally open contact and then we will connect it like this. So here we will assign address to it as I0.2 and that is C. So here this is AB plus C. Plus C means OR logic gate, or it means it is connected in parallel with this AB. So now let's do the simulation here. I will start the simulator here. So for output Y to be on, either A and B both should be on or only C should be on. So for output Y to be on, if only C is on, then it will be on. So let's click on load and then finish. After that, I will start CPU, OK, and then I will turn on monitoring. And then I will switch to this project view. And then I will create a new project, create, And then I will go to simulation table and simulation table 1. And then I will right click here and then load project tags. And now we can start the simulation. So here, when I turn on A, nothing happens. The current will flow through this, but output Y will not turn on. And then if I turn on B also, then the current will flow through it, and as a result, this output Y will turn on. And then instead of turning on A and B, I can turn on C only, then also the current will flow through it and output Y will be on. So for output Y to be on, either only C should be on or A and B both should be on. So if A and C are on, then output Y will be on because of the C. So if only C is turned on, Y will be on, or instead of C, if C is off, then A and B both should be on to turn on the Y. So now let's move to another example, that is Y is equal to A, B, C plus D. So there is AND gate between A and B, C plus D. And there is one more AND logic gate between B and C, and then there is OR logic gate between B, C and D. So firstly, B and C will be connected in series, and then with BC there will be connected D in parallel to BC, and then A will be connected in series with BC plus D. So let's move to TIA portal. So here we will insert a normally open contact and it will be A, and then I will insert two more normally open contacts, that will be B, and then it will be C. And then I will open the branch here, and then there will be one more normally open contact and that will be D. And then I will connect it in parallel with C and D. C and D. It will be in parallel with B and C, not A. So then here we will insert a coil for output Y. Output Y. So here this A should be on. This A is mandatory, it should be turned on, and then there is a choice. If B and C are on, then output Y will be on, and instead of B and C, if D is on, then also Y will be on. So, in short, if there are two conditions, if A, B and C, all the three are on, then output Y will be on, or there is one more choice that if A and D only are on, then also the output will be on. So, let's start the simulation. I will start simulator and then load, finish. And then I will start CPU and then once again start monitoring and then switch to project view. I will create a new project here. And then I will go to simulation table and simulation table 1 and then I will load project tags. So now here when I turn on A, nothing happens, and then when I turn on B also nothing happens, and then when I turn on C the output Y turns on. And then instead of B and C, I will turn on D, and then also the output Y will be on. And then if I turn on B and C only, not A, the output Y will not turn on. So turning on A is mandatory, and then we have a choice. So if only D is turned on along with A, the current will flow through this and output Y will be on. Or instead of D, I will turn on B and C, and then also the output Y will be on. It was all about this example. Thank you for watching.